March 2021, the Department of Basic Education released the draft Coding and Robotics curriculum. In this video, we will review the draft Coding and Robotics curriculum to give you a better understanding of the subject and the content. What is coding and robotics? The aim of the subject: to raise digital citizens who can function in a digital and information-driven world. This is crucial because this subject, they will study activities that will deal with solutions of problems through logical and computational thinking. So the emphasis here is on critical thinking and problem solving. What is the basis of the curriculum? In the foundation phase, the coding and robotics curriculum is built on 5 pillars. These are pattern recognition and problem solving, algorithm and coding, robotic skills, internet and e-communication skills, and application skills. The basis for this curriculum for both the foundation, intermediate, and senior phase is computational thinking on engineering and design processes. And that is crucial because throughout the curriculum, they touch on the technological process for solving problems and for finding solutions to problems. Note that in the intermediate and senior phase, we only have 4 pillars. Pattern recognition and problem solving is only for the foundation phase as a standalone pillar. Yet pattern recognition and problem solving forms the basis for the algorithm, robotics, internet and e-communication, and the application skills. So even though it's not a standalone pillar in the intermediate and senior phase, it does not mean that the principles taught in the foundation phase for pattern recognition will disappear in the intermediate and senior phase. Here is a summary of the 5 pillars as they relate to each of the phases. Note that in the foundation phase only we have the pattern recognition. The emphasis of pattern recognition is to help learners to solve problems. They must be able to identify and create their own patterns. Algorithms and coding in foundation, intermediate, and senior phase, the skills in one phase to the next is scaffolded. In other words, it means that the skills taught in the foundation phase is further developed in the intermediate and senior phase. In the foundation phase, learners work with physical coding practical activities, and that progress from grade 1 onwards as they start to engage with coding. In the intermediate phase, they work mostly with block-based coding. Examples of software that can be used is Scratch or Blockly. And the block-based platforms make use of easy to understand drag and drop type coding where learners can focus on getting the details and correct input in the programs. In the senior phase, you build on these skills with block-based and now start to gradually transition from block-based coding to text-based coding. The robotics. In the foundation phase, robotics consists of 2 fields, coding and engineering, and the learners are introduced to certain mechanical and electrical engineering systems. They are introduced for the first time to circuits and how circuits are used in robotics. And the robotics strand primarily uses the engineering design process. In the intermediate phase, the learners are introduced to microcontrollers that they can code with block-based coding. And in the senior phase, they continue with microcontrollers, but now they transition with more advanced sensors that needs to be programmed and how they can program those sensors making use of text-based or line-based coding. The application skills focus on how to use a computer or how to use a device. In the senior phase, the learners also focus on HTML or web development and how to create or design their own website. Internet and e-communication skills prepares the learners to interact safely in a digital, online or offline world. Here is the time allocation or the weighting of the 5 pillars for the foundation phase. In grade R, pattern recognition and application skills receives the highest weighting at 30% each, and Coding and Robotics at 10%. In grade 1, the majority focus is on pattern recognition and application skills. More time is allocated for robotics at 15%. Grade 2, more time on algorithms and coding and application skills, and even more so for robotics, now at 20%. The grade 3s, look at that as spreading. 20% is for application skills, only 10% for pattern recognition and problem solving, and 35% now focus on robotic skills. What about the intermediate and senior phase? From grade 4, the children also need to complete a PAT and assessment, the practical assessment tasks. They will also write tests and an exam. And here you can see the time allocation. 30% is spent on robotic skills, 20% on application skills, and also on algorithm and coding. Grade 7, 30% on robotic skills, 25% on algorithm and coding, and for grade 8 and 9, algorithm and coding and robotics at 30% each. In the PATs and the exams, the children will do a combination of all the pillars. I just quickly want to look at the robotic skills and just point that out, that the robotics at the foundation phase level is on playful discovery, where the children are also introduced for the first time to circuitry. They will work with batteries and switches and buzzers, and in grade 3 even have to work with LEDs, resistors, and a breadboard. In the intermediate phase, note that we've said that 30% of the time allocation is on robotics and coding. But that 30% is probably closer to a 15% only being spent on robotic components, and the other 15% is spent on structures, mechanical fasteners, for example, also working with pulleys, linkages, and gears. And in the senior phase, it's also 30% allocated to robotics, but as explained for the intermediate phase, you should regard it as a 15 and 15%, because the focus is on robotics as well as CAD drawing, computer aided design software, so that you can at grade 9 level make use of a 3D printer. And this is a summary of the draft coding and robotics curriculum as released in March 2021.